Hi Rockridge, this is Mrs. Berger, and today we are going to wrap up our unit on radicals by doing part 2 of the Solving Radical Equations lesson. So hopefully by now you've made it through your warm-up and you've been reminded of how to solve radical equations. So let's take this one step further today. And we will look at, so last time when we were faced with roots, we counteracted that with powers, so reciprocal powers. Now we're going to have variables being brought to exponents, and we'll need to counteract those. So let's see how that works. So as you might imagine, to counteract a power of 2, we would bring it to the 1/2. So we would raise that to the 1/2 power. And the same thing would happen over here. We would raise 25 to the 1/2 power. Now, the other way to do that, of course, is to take the square root of both sides, right? Because being raised to the 1/2 power is the same thing as taking the square root. So when we do that, we end up with, of course, x equals 5. But we have to be careful when we're doing this, because there are actually two answers for x that could possibly cause a 25 here. You could have positive 5, and you could have negative 5. So when we counteract these powers of 2, these even powers with roots, we need to make sure that we have a both positive and negative option for our answers. Okay? So this will get more complicated, but this is obviously the introduction of this necessity here. All right, so again, solving means we're doing PEMDAS in reverse, right? We're isolating x by doing PEMDAS in reverse. So this 3x squared minus 9, the first thing I need to take care of is the adding and subtracting. So I'll add 9 to both sides. Then I'll hit the m and the d, the multiplying and dividing. I'll divide by 3 on both sides. And then I will need to counteract the e part, the exponent part, I'll need to take the square root, or the 1/2 power of both sides. But just remember, when I do that, I have to have both the positive and negative square root of 15. Okay? So account for both of those when you have even roots. Let's look over here. Once again, we would need to add and subtract first. Then multiply, divide. Then take care of the exponent. We're going to take the square root of both sides. We need to make sure we do the positive and negative 2. That is the answer. And if you plug both positive and negative 2 in for x, you'll see that that's the answer either way. All right, there's nothing to add, subtract, multiply, or divide here to isolate, so the first thing we need to do on this one is counteract the power with a root. And watch what happens here. So we have x plus 3 on the left, and we have positive and negative 2 on the right. Now, in order to finish solving, I've got to isolate x still. This phrase on the left equals both positive and negative 2. So what we'll need to do is to find the two answers for x that solve this. We would need to take x plus 3 equal to 2, and x minus 3, x plus 3 equal to negative 2. I got excited about the negative. So x plus 3 equals positive 2, and x plus 3 equals negative 2. We need to solve for both of those, because there are two different things x can be to make this statement true. So of course that means x must equal negative 1, or x must equal negative 5. And if you were to put either one of those back in here, you would see that you would get a true statement. So both of those are your answers for number 4. And again, we found that because when we took the square root, when we counteracted this even power with the square root, we remembered to put plus and minus on the right-hand side. Now number 5 starts off with a necessity, a need to divide by negative 3. Remember, PEMDAS in reverse, we take care of the m and the d before we hit the e. Okay? So we'll have x plus 2 is equal to 27, positive 27. And then in order to counteract that power of 3, what do you think we need to do? We need to raise it to the 1/3 power, or if we're not doing the 1/3 power, let's Let's do the cube root, right? Because that makes a little more sense to us sometimes. If it makes more sense to you to raise it to the 1/3 power, that's fine. They're the same thing, right? So we're going to take the 1/3 power of each side. And remember, you're raising it to the 1/3 power. You're taking the cube root. You're not multiplying by 1/3. Be very careful about that. Lots of mistakes are made. Raise it to the 1/3 power. Take the cube root of both sides. All right, so that will go ahead and break out your x plus 2 is equal to 3. Now, with the odd roots, we do not have to accommodate a plus minus, right? Because you could take an odd root of a negative number and just get a negative number. So that's the difference between counteracting odd things and counteracting even things. With evens, you could possibly have two answers. With odds, there's only one answer you could possibly get. There is only one thing that could cause the cube root of 27. So if we subtract 2 from both sides, we get x equal 1, and that is the one single answer to this question. Okay? And if you plug that back in, you'll see that. All right, number 6, once again, we have something that we need to do multiplying and dividing first, right? So that we have x minus 3 squared on the left and 16 on the right. We need to counteract the power of 2. And when we do that, we get plus and minus 4 on the right. So now we need to break this out because there are two different ways this could go. It could be positive 4, or x minus 3 could equal negative 4. So the two answers that will make this a true statement are positive 7 and negative 1. If any of that went too fast for you, if you wanted to try that on your own before looking at the answers, please do pause and rewind. Make sure that you're super comfortable with counteracting these powers with roots to dig these answers out, okay? Because we're about to get a little bit more difficult. We're going to introduce the concept of extraneous roots. So back up here, these x equal positive and negative square root of 15, x equal positive and negative 2, these answers, these solutions for x, those are called roots. Those are roots of the equation. An extraneous root is a root that makes an equation false when substituted back in. So if you solve, and get an x at the bottom here, and you take that x and you plug it back into the original, and it makes a false statement, something that doesn't equal the number on the other side, you have found an extraneous root. So the steps for this are similar to what we've been doing. We're going to solve the equation for x, and then when we're finished, we're going to plug the x back into the original to see if we've got a true statement, to make sure we don't have any extraneous roots. So let's see how that works. Same as we've done before, if you've got the square root on the left, in order to counteract that, you need to raise it to the 2 power. Whatever you do to the left, you need to do to the right. So you should have x minus 5 equals 144. If you add 5 to both sides, you've got a temporary answer of 149. Before you circle this as your final answer, you should always check. So check back in the original equation. Is the square root of 149 minus 5, is that equal to 12? That's what you're checking. Is the square root of 144 equal to 12? Well, the square root of 144 is 12. So you've checked it off. You may go back and circle this as your answer. You don't have any extraneous roots. Okay? That's what we mean by check for extraneous roots. And you'll need to show this work. Even if you do end up with x equal 49 as your answer, you'll need to show this work if we ask you to check for extraneous roots. Okay? All right. Let's continue our work. In order to counteract the cube root, we need to raise to the 3rd power. Whatever you do to the left, you have to do to the right. 2x plus 4 is now equal to negative 27. 2x equals negative 31. X equals negative 31 halves. So right now, this is our answer, negative 31 halves. We'll need to check this by plugging it back into the original. So is the cube root of 2 times negative 31 halves plus 4 is that equal to negative 3? That's what we want to know. Well, let's see here. If we multiply 2 times negative 31 halves, that's just negative 31, because the 2's cancel. And if we combine negative 31 and 4, we get negative 27. And the cube root of negative 27 is, in fact, negative 3. So we have checked it, it works, and we'll go back and we'll circle this as our root, or as our solution. It's not extraneous. Let's take a look at number 9. Number 9, we need to counteract this fourth root by raising it to the 4 power. And whatever we do to the left, we must do to the right. So on the left, we have 2x plus 1. And on the right, we have 2 times 2 is 4, so positive 16. Solve for x, and you'll get down to 15 over 2. So that's currently what we're saying our answer is, but we need to make sure we check by putting it back into the original. So the fourth root of 2 times 15 halves plus 1, does that equal negative 2? Well, this is the fourth root of 15 plus 1. Does that equal negative 2? That's the fourth root of 16. Does that equal negative 2? Well, the fourth root of 16 is positive 2, which does not equal negative 2. So this is not a true statement. When we plug this 15 halves back into the original, we did not end up with a true statement. So we cannot count that. This is an extraneous root. And since this is the only root we found, there is no solution to this. So because the only root we found turns out to be extraneous, we say there is no solution to this problem. Okay, we found an extraneous root. Otherwise, the roots we found were good. They checked out. They caused true statements. So we went back and we circled those as our answers. But since this answer caused a false statement when plugged back in, we don't have a solution to this. Okay? All right, let's take it one step further, and then you'll be good to go on your homework. So let's take a look at this. We dabbled in this a little bit last class. So let's remind ourselves how we take care of these crazy 3/2 powers. Hopefully you recall that in order to counteract that power, we raise things to the 2/3 power. And whatever you do to the left, you must do to the right. Okay? So you have freed this from that nasty power on the left, and you're now being asked to take the cube root of negative 8 and square it. So 3x minus 2 equals, the cube root of negative 8 is negative 2. So 3x minus 2 equals 4. Add 2 to both sides and divide by 3. So right now we are saying that our solution to this, so number 10, is x equals 2. We will want to make sure that we check this problem, check this solution before we circle it. We want to check to make sure it's not extraneous. So we go back to the original. Before we did all this crazy power, reciprocal power stuff, we're going to go back to the original and plug 2 in for x and see if we get a true statement. Does that equal negative 8? That's the question. So let's see, 3 times 2 is 6, 6 minus 2 is 4. So 4 to the 3/2 power, does that equal negative 8? Well, that means the square root of 4 raised to the 3 power, does that equal negative 8? The square root of 4 is 2. 2 to the 3rd power, 2 to the 3rd power is positive 8. That does not equal negative 8. So this actually does not, when we plugged the red 2 back in there, we did not get a true statement. And so therefore, we do not have a solution. This is extraneous. and we say no solution. Okay, if you need to pause and go back to any of that or slow it down, please do so. And from now on, you should always check to make sure that these roots work out. When you are confronted with something to the 3/4 power, in order to dig this x out of this mess, you're going to want to raise it to the 4/3 power. Whatever you do to the left, you must do to the right. So x plus 5 is freed, and you now have 27 to the 4/3. Please don't make the mistake of multiplying 27 times 4/3. Make sure you take the cube root of 27 and raise it to the 4th power. Okay? I'm actually going to let you follow that through, and you can go ahead and check that against the key, but follow this through, find out what your answer for x is, and then check it. Now, I will also get you started on this one, this number 12 over here. I want you to follow PEMDAS in reverse when you're digging x out of this mess. So you'll want to hit adding and subtracting first. So please subtract 6 first. And then hit the M and the D, then multiplying and dividing. Divide by -3 next. And then counteract. You choose. I'm going to let you finish this one. You choose what power you need to bring both sides to. Make sure you bring both sides to that power. Don't be multiplying by whatever fraction you come up with. You're raising it to that fractional power. So I'm going to let you go ahead and finish that out. Find out what your answer is for x, and then check for extraneous roots. Check your key, and then try your independent practice.